Okay, we're back to this is part three. So let's see if we can pen to work. I'm not sure why it's not working. Yes, part three. So we're going to talk about sublimation and deposition. Sublimation is basically when something goes from a solid form directly to uh, trying to learn this pen here. So here we have some dry ice, and here you have dry ice. We can see dry ice solid directly goes to vapor phase or sublimes, or what it means that going from solid to a gas. So that's what the sublimation is. Now, what is melting or fusion? Melting is when we heat a solid, the solid gets melted or becomes a liquid. So once the temperature again reaches the melting point, we get enough energy to the molecules that they basically vibrates and become a liquid. And then the opposite basically is the freezing. And we can see that on the road, winter is coming up, and the road can get basically the cold days icy, so the water freezes, or the ice can melt if the temperature goes a little bit higher. And we see that in winter time here in New Jersey all the time. Now, what is the heating curve? So the heating curve is when we start with basically a solid here. We're going to talk about that. Then here is the melting basically. We start at 0 degrees and all the way to 100 degrees, right? So this would be the liquid part. And then we going to do some practice, I believe, in ACS, and that we're going to have. So we're going to look at the Q, the energy is equal mass of water, basically, if it's we're using water. Constant, this constant is given to us times change in temperature. Once all the liquid has been turned into liquid, then we're going to heat that and then we're going to get steam. So there are some more pictures of this later on during the slide presentation. So again, what is the heat of fusion or melting? So that's what we call the delta H of fusion. So delta H of fusion basically, or the melting or enthalpy of fusion is a positive number because why is positive? Because we have to give it energy to it. The opposite is crystallization. So once the liquid form crystals or water forms ice, we can say that delta H or enthalpy of the crystallization is equal as delta H of fusion, but we put a negative charge here because that's what we have to give it energy to. On the other hand, crystallization gives energy out. And then if you remember the sublimation, so delta H sublimation is of both of these, fusion and vaporization. So because we have to melt it first, become a liquid, and that liquid becomes a vapor. So it's the sum of the two. Again, this table 9 is telling us something about the temperature of the melting point and delta H. We can see water, we need 6.02 kilojoule, and a little bit less for the isopropyl alcohol, and a little bit more for acetone, and a lot more for ethers. A lot more for ethers. And here's what I was talking about, the heating curve. So here in this corner here, we start at the ice. We start as the ice. And then ice over here, we heat the ice, it melts. So we're looking at this a little bit later. So we call that step 1. So this is my step 1. Then once we have the liquid, so the liquid start heating in step 2. Now here, At this point, we start the liquid. We start the heating the liquid. So that's my step 3. So in step 3, we go from basically water all the way to boiling water. So we start here. Now we can see the steam is coming up. So now we can see that we can take this, and step 4, heat the water, boil till we get to step 5, which is now a steam. So we can heat the steam. So we have 5 different steps here, and then we have a little picture here to show the ice, basically water heating, and then at the end we have the steam. So we're going to look at this individual steps here. The first step, as you recall, is the ice. So we start with the ice. We heat the ice to get to melting the ice, to melting ice. The equation we use is Q. Again, the Q is mass of the ice times a constant, this constant different for different material, times delta T, change in temperature. We were told that the constant, or C sub S, is 2.09 joule per mole per degree C. Now if I put all these things here in this formula, so 18 grams basically is for 1 mole of ice. We multiply it by this constant, multiply it by change in temperature. So we went from a 0 degree to 25 degrees, which is room temperature. So we get about 0.941 kilojoules. So we need that much energy to melt the ice, basically, right? Now remember, the first one is joule. Now we can divide this by 1,000 to get kilojoules. Now in a step 2, now this, what we call a step 2, is here. So we start with the water at room temperature, heating it. Again, we're looking at 1 mole. Now it's a little bit different Q here. So Q here for this step is N, which is number of moles, times delta H of fusion, we talked about in the past. So N again is 1, delta H of fusion we reported as 6.02. So the Q would be now 1 mole of the water, be heating it, and delta H of fusion for 1 mole is 6.02 kilojoule. So this would be, this Q from here to here would be 6.02. So let's get step 3. So step 3 was when we heating the moles of water at 0 degree to the boiling. Now this, remember previously when we have here the the melting process. See this one? Temperature stays the same, so temperature really doesn't change. It stays 0. Start with the ice, and here's all water, but it's still 0. So temperature really constant. Temperature doesn't change. So now we're going to change the temperature, because now at this point we're going to heat it, right? We're going to heat the water. Start with this at 0 degree all the way to 100 degrees. So we're making T. So again, we have a constant is 2.09. We know what delta T is, and we know C is, and we know what the mass is, right? The mass is 1 mole. Then the constant is 4.18 times the difference in temperature. So this constant is different than the one before, remember? Now, if I do all this equation and calculate, so I get basically 7.52 going from joule to kilojoule. So we need this much energy to go from a 0 water to 100 degrees water. So that's what's textbook called it step number 3. Now let's go look at step number 4. So in step number 4, where basically we keep the water at 100 degrees. Now the temperature again doesn't change. The temperature doesn't change. But when we get to this point here, now we're going to have a steam and we can heat the steam. And that's what we do for electricity actually. So step 4, again, we go back to the delta H of vaporization, not diffusion, vaporization. Again, we have 1 mole and we know that delta H is 40.7 as measured for us. So now if I substitute the Q, then energy I need to supply is 40.7 kilojoule for 1 mole of water. So to get from here to here. Remember, it's my step 4. So the temperature doesn't change in the step 4. Then we go to step number 5, which is the last step. Let's say we're going to make electricity. Again, the Q is a constant, mass times a constant times changing temperature. The constant now is going to be different. The constant here is 2.01. We use a different constant, remember. So now again, we have 18 mole of water constant, 2.01, the change in temperature. Let's say we're heating it up to 125 degrees C. So again, 904 joules or 0.94 kilojoules for this step. Okay, phase diagram. So what is a phase diagram? That's what we just talked about. A phase diagram basically is we start with the solid. Where's my little pen? Then we heat it. So this is my temperature here, right? So the temperature goes to the right and the pressure on the left side, the y-axis. So it really is a nice thing because we can see in this light blue area is a gas. The liquid is, they show it as a light blue and the dark blue for solid. So if you look at the water, for example, at 0 degrees, right? Temperature 0 degrees, right? If you go all the way to the top, so we get to this point. So at this point, that's what we talk about, right? At 0 degree, we can see the water as a solid, as ice, and water as a liquid are in equilibrium. And that's how we find it. Now, again, we talk about 760 millimeter mercury. Maybe I said the wrong number. 760, right, 760. Now, if I draw a 760 line from here to here, so this would be the point that basically the liquid water and gas water as a steam are in equilibrium. Basically, we're boiling the basically liquid to make it gas. And this phase diagram is always like this. We have a gas, we have a liquid, and we have a solid. And that's the same for all phase diagram that we're going to study for this class. So again, what would they tell us about the phase diagram? We have a liquid, solid, liquid, gas. So what is this triple point that the authors and many books talk about it? The triple point is when all of them are in equilibrium. So we have a solid, liquid, and gas. So this is where everything stays together. So this phase diagram is really helpful. It tells us the relation between gas and liquid. It tells us the relationship between solid and liquid, and solid and liquid. So all the three of state that we talk about are described here. What does the fusion curve means? Again, the fusion curve means melting. So going from a solid to a liquid. What is the sublimation here means going from a solid directly to the gas. And vaporization curve means going from a liquid to a gas. So all these things are described in this phase diagram. So here we have some other idea about the boiling point. We talk about boiling point. So the boiling point basically room temperature is shown here. And we can see the water because the hydrogen bond has very high boiling point, 100 degrees atmospheric pressure. Then we go down to H2S, and all of a sudden you can see that it's a gas. And the molecule gets bigger and bigger, and you can see the boiling point goes a little bit higher. And we talked about HF in the past, and ammonia and methane. Because there is no hydrogen bonding in methane, it has very low boiling point. Versus ammonia is a little bit higher, a little bit less than 0. HF is right about 20 something, 25 or 19. Then we have the water. And then we can see this curve follows the pattern of the size of the atom. And this was my part 3 of the chapter 12. The next thing I'm going to put together is basically to talk about the homework that we're going to do for Monday. Stay tuned. Thank you for listening.